Let's turn now to one of the most practical key concepts in microeconomics, the price elasticity of demand. In fact, this key concept has tremendous applications in the pricing and marketing strategies, not just of businesses. It also helps government agencies set things like mass transit fares and sales taxes. So let's start out by just thinking about the word elasticity. If you pull back on a rubber band and then let it go, it snaps forward pretty smartly. It's because it's pretty elastic. But if you pull back on a piece of string, it only snaps back a little bit. It's pretty inelastic. Well, the price elasticity of demand simply measures how much consumers will increase or decrease their quantity demanded in response to a price change. A big change means demand is elastic, like the rubber band. In contrast, a small change means that demand is inelastic. There is, of course, a very complex formula to calculate the price elasticity of demand, and I will show you that soon. But before we go down that math road, let's really nail this down from a much simpler, intuitive perspective. So take a look at these two demand curves, one for cigarettes and the other for beef. And please study the slopes of these demand curves very carefully now. What do you see? Well, in the first graph on the left, the demand curve for highly addictive cigarettes is very steep. In fact, the cigarettes demand curve is almost vertical. In contrast, in the second graph on the right, the slope of the demand curve for beef is relatively flat. So here's your question. Given the shape of these curves, in which market do you think the quantity demanded will respond least, and which market will respond the most to a change in price? That is, which good, cigarettes or beef, do you think is relatively more price elastic? Did you get it right? The demand for beef is certainly much more price elastic than that of cigarettes. To quite literally see this, take a look at this figure as you imagine that the price of cigarettes rises by $1. In this case, you can see that the quantity demanded changes very little. In contrast, you can clearly see that $1 increase in the price of beef results in a huge decrease in the quantity demanded. Now here's the general formula for the price elasticity of demand. It states that the price elasticity of demand equals the percentage change in the quantity demanded divided by the percentage change in price. Let me say that again. The price elasticity of demand equals the percentage change in the quantity demanded divided by the percentage change in price. So riddle me this, Batman. Why do you think that this formula is stated in percentage terms rather than absolute terms? Please pause the presentation briefly now and contemplate what is actually a really interesting question and riddle. So, did you figure out why the price elasticity formula is stated in percentage rather than absolute amounts to measure consumer responsiveness? In fact, there are two very good reasons for this. One has to do with the so-called unit of measure problem. The other has to do with what's called the choice of units problem. Let's explore the unit of measure issue first with a quick example. Suppose the price of cement falls from $3 to $2 and consumers increase their purchases from 60 to 100 pounds. It may appear that consumers are very sensitive to price changes and therefore demand is elastic. But now let's change the monetary unit from dollars to pennies. In this case, we could just as easily say that a price change of 100 pennies caused a quantity change of only 40 pounds. giving the impression that demand is inelastic. The key point: by using percentage changes for both price and quantity, we are freed from worrying about what the correct unit of measure might be. Pounds, bushels, tons, whatever. Nor do we have to worry about what the unit of measure for price is, whether it's pennies or dollars or centavos or rubles or yen. As for the choice of units problem, another quick example will help explain this issue. In this case, consider the effect of a $1 increase in the price for a $100,000 Ferrari automobile versus a $1 increase in the price of a $1 carton of milk. Here, the price of both products has risen by the same amount, $1. However, the price of milk has risen by 100%, while the price of the Ferrari car has risen by a minuscule percent. So it is certainly better that we compare the price changes of both products on the same percentage basis, say 1%, to determine how consumers will respond to the price change. In fact, that's exactly what this elasticity formula allows us to do. Study it for a bit now, and when you're ready, move on to the next module in this lesson, and I'll break that formula down piece by piece for you in a way that allows us to better understand what actually determines price elasticities in the marketplace. A key piece of information for any of you would-be business execs out there in search of a competitive pricing and marketing strategy.